Right, welcome back, and we're still talking about chemical reactions and rates of chemical reactions. Now, here we're still dealing with how to interpret graphs, and I'm actually having for you 3 types of graphs. The previous one that I did with you on the rate of reaction, how much of a substance has been formed over a period of time, and now I'm bringing you something that has to do with energy injected into a chemical reaction. And of course it will have something to do with temperature, because obviously when you put in energy into a reaction vessel or reaction mixture, normally it is in the form of heat, so that alters the temperature of the system as well. And lastly, we will be going back to be looking at the potential energy changes between reactants and products, so that we can close this section and you can be sure you understand what is entailed in those type of section in physical sciences. Now let's look at this one here. The kinetic theory and the Boltzmann distribution curve. Now more often, learners tend to find difficulties in interpreting this type of graphs, and rest assured they can be in the exam, and you are expected to interpret it and make sense of it and answer questions based on it. So listen very carefully and go through this with me in an attentive way. Now look, here we have got fraction of molecules with a given kinetic energy, and here we have got kinetic energy. In other words, we have got this as a function of kinetic energy. And here I've got that broken line there, which represent the minimum amount of kinetic energy needed for a substance or for a molecule in this reaction to react. So once it has got this, it can be able to react. In other words, if a molecule has got any energy at that point or greater, kinetic energy at that point or greater, reaction can occur here. The reaction can occur here. But anything with energy less than that, which is in this territory here, all this, no reaction can occur there. Okay, so the barrier here is this dotted line here. Now, if you look at these 2 graphs here, X and Y, in which situation are we having more of the molecules having less than enough kinetic energy? In which graph? Now let's trace X. You go through X there. That's how X moves, and you are somewhere there. And obviously this part here gives you the number of molecules given by graph X that are ready to react. But when you look at Y, let's look at Y. There is Y. Y up to that point. So Y, this whole part, the lines, not the axis, it's for Y. Y has got more molecules with the required EK to react. But X has got only this part, just that little. Okay, so X has less molecules with the required EK, whilst Y has got more molecules with the required EK. So reaction is more likely to be faster. Reaction Y will be what? Will be faster than reaction than X. That's what it means. And if you look at this thing thoroughly again, it also tells you that it is very difficult to get most of the molecules, which is this bulk of molecules here, for both graphs X and Y to have the required amount of energy for them to react, because only from this point this way will a reaction take place. But anything going this way, no reaction taking place. You have got more of these molecules here. Now, how do you ensure that most of these molecules go beyond or cross that barrier, that borderline? You can put in more heat. You can heat up the reaction mixture. Okay? So what factor are you dealing with here? It's temperature. Okay? Or you can do all other things like all those factors that we spoke about. If you have got solids here, you can cut them into pieces or grind them into powder so that you increase the surface area for reaction, then you're getting more of them to react. But this one here, this curve here, specifically deals with kinetic energy. I mean, that fraction of molecules with a given kinetic energy as a function of kinetic energy there. And therefore, this will have to deal with temperature. You heating it up or you cooling it off. Okay, in that way, you can speed up that rate of reaction. Right, that's all I had for you for today. And let's meet in the next lesson. That will be lesson number 17. As from me, Tinyiko Kosa, keep well. Bye-bye.